Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Shankleberg, barely able to hit record before we dove into this topic.
And this is Kirk Gray.
Not
hey,
Ray.
Fred.
It's not Ray like you taught me last episode. But
right.
It's
Kirk Gray.
Kirk.
And that's
right.
with an A.
Right.
Anyway, yeah, you were talking about...
So we sent out a question this week. As Carl and I are kind of trying to wrap up the draft of this book we've been working on, seems like forever, and we've got some ideas for a title of it, but we thought, well, we can get some more ideas. So we have all these people that have read the draft so far. Let's ask them, and we got some really good ideas right away, and so we'll go back out with a narrow set for some voting. But one of the pieces of advice was include at least one or two buzzwords of current fad things today, like Internet 4.0 or artificial intelligence or data engineering or I don't know, some other bunch of other,
Right.
And I was like, no, I got nothing to do with any of those things. And then coupled with that, I ended up with this question came up the other day it was kind of bouncing a recommendation of what they were thinking of doing in this organization that doesn't really have a FRACAS system or a field data tracking system. And it's not a very big company, and they don't have that many installed systems. So they're getting on the order of one a day, of alert or order of magnitude wise. So they're not getting a million calls or returns or anything like that. They're not anywhere near that scale.
Okay.
And they don't have a FRACAS system. They don't have I'm trying to think of the name of the acronym. It's
Reporting and Corrective Action?
Yeah, system, FRACAS. And so and it's a small company, and there's only a handful of folks, and they get an issue, they go talk to Bill, and then they talk to Sue, and they solve it, and they move on, or they work on it. And so the idea was to install a automated, once the data is input, the information's input, then it would create pretty cool visualizations was the idea. And if you've ever seen this software package called Tableau, it makes beautiful graphics. It does. If you've got great data, it'll make beautiful graphics.
Oh boy.
And it's like, and it was the license was $15,000 a year, and it took, you had to be trained, and I played with it once. It does really cool stuff, but it's got a steep learning curve to make it do really cool stuff. I mean, I can do a bar graph pretty easy, but I don't need a high-end, high-zoot software package with...
No, they still have Excel, I think, is available.
Well, that's even too much for me. I like a piece of graph paper. But it's been my long-term... and I'd like to get your impression of this, is okay. You got to learn to walk before you run. Do it manually. Right. Make sure the system works. Make sure you got a good source of data and you got a good process in place. Right. And then automate where it actually helps. But the other one is what are the other meaningful solutions to this problem of what should I work on? How do I see trends? If they're not even using a Pareto of what they're seeing now, that might be a really good first step. And then it'd have the upgrade to fancy graphics may not be as valuable then, because it's not providing, it gives you the next 1%, but it's not worth the effort. If a very simple basic tool on a piece of parchment works just fine for 90% of the stuff you're trying to solve. Right.
And so there's one, I'll just automate this sort of thing and kind of, and especially in reliability, you just can't do that. It's just not.
Oh no! Now we've got AI. We've got all this computing power, and they can self-learn and all this good stuff. Yeah, they can solve it all for you.
Well, it may be able to self-learn after you've known the problem and known the cause of the failure or whatever, and be able to document and put it in there in its in its database. But if it hasn't ever happened before, and there's so many things, I mean, reliability or unreliability is unexpected in almost all products is you build it to be reliable. Yeah. And so it's an exception. It's an outlier. It's something that doesn't follow the norm. And it requires a lot of questions, which the software could ask you, or you have to know, you have to do, and unless you have, this robot that could, pull apart the thing, look at the solder joints, or look at whatever it is, or look at the software and say this error is because some, logic gate here is, is having an, this particular section of the computer or this server or whatever is having a problem, then you might be able to identify, especially for soft errors, things like that.
Well, yeah, and there's diagnostics we stick in equipment and everything else.
Right. But
that's
we've
not
got to
the
be
whole
able to
game.
repeat it.
Yeah, and that's not the whole game. I don't think this was to replace failure analysis or anything else. But let's say
what advantage? What would be the advantage of whatever they're,
Well, the argument was that it would give you a visualization to give you greater insight at what's happening with your field data, your field failures over time. And you're like, okay, well, they're not doing that now. Oh no.
Yeah.
Then why did they need to jump to the, fifth level of effort to actually get that? That was my first point. And it says, now it may prove out to be exactly what they need and just beautiful, insightful, and clear as a bell and everything else once you get it set up. But instead of automating it right from the start and going through all this pacing to get everybody to get the data just right so it goes into this program just right, how about do it manually for a couple months and see if it actually gives you anything?
Yeah. And basically, if you're talking about a small, like you just mentioned, a small production, not putting out much, then they have the opportunity now to learn the really fundamentals of their product and fundamentals of the problems without, in fact, and when you get into massive volumes, then that's when data sorting and being able to use software to
look at it different
identify
ways.
and Paretoize it and things like that would be more useful because you've got a massive amount of data and you can't review every one of them. But if you have just a onesie twosie or 5 a month that you can investigate, I mean, this is where you start learning, especially in a new company, before you jump up into hopefully you're going to go to mass production if it's if you're making electric vehicles or something like that.
No, it's not even that. It's not even that. It's just a company that has a very niche market, and the hardware supports the services they sell. So it's not their intention to make a gazillion of these ever. It's just that's not the business model they're in. So it was.
What's the failure cost? What's what are they trying? What's the cost of the problem they're trying to address? Is it $15,000 a year for software? I mean, what advantage is that going to give them besides the pretty graphics? Which, you should be able to understand before you get pretty graphics what just the raw data says, the numbers, until you put it into a colorful chart, and where those numbers are coming from, and why they're, what's the issue?
Well, one of the things with the fancy software packages, and I've worked with a handful of different ones that allow you to do, you say you have the region that came from the board that it was on, and you get like 10 pieces of information about the week it was made, all this other cool just data associated with this particular failure, and all this cool stuff. And one of the things we often do, and I know you've done this, is you get a bunch of failures and you notice they all come from Kirk Gray's kitchen, and then it's always, and they're like, what are you guys doing in here?
What's he making?
What's he making in here? What are they doing? And
crushing rocks.
But if the failures were scattered all over the world and they were nondescript and not similar in any way, not associated with the same week, whatever, it's totally random. But it's one of the things we often do is go, is this a batch problem to this week of production? Was this the week we had some bad components come in or a change in the line? Or we do a lot of that kind of stuff. And the higher end visualization packages can help you spot apparent relationships. I won't even say causations because it's not representing causations. It's just connections or relationships. And there's lots of different techniques for doing this with when you have 20 pieces of information on 1,000 different failures.
Right.
You can look for patterns in that.
Right.
And then you may go do investigation, see if those are realistic or not. But it's
when you have a lot of data, that is a good time to use a kind of a software that can sort and reduce and make it into identifiable areas instead of, especially if you're having, tens of 10,000 or whatever. That doesn't make sense for these big companies doing mass production of consumer products or something like that.
Yeah. But the idea is
Tuesdays,
the onesie
you do the investigation.
Yeah, but we use tools to look at all these different. Is it only from Europe or is it only here or only there? And these tools help in those regards. There's no doubt about it. But here's what I think is the issue: is if I have 20 different pieces of data, it is very likely I'll find two things that are that appear to be related in some way. Oh, if we send to Europe, we get a higher failure rate.
Right.
That could be completely coincidental because I'm comparing so many different things. So did you go to high school, Kirk, in like the late 60s, early 70s in that time frame? Oh, I did too. Imagine that. Yeah. We must be cousins. Right. No.
Right.
It's coincidental.
Right. Coincidental versus causational, whether it's, they're just because it's concurrent runs together, it's not necessarily a cause.
Yeah. So I ran into this once where they were looking at a pile of data, and this was not using fancy anything, but it was like they noticed that it was 1 week of production that they had a big spike in failures from.
Okay.
And so they immediately blamed, there was a couple of components involved with it. So they immediately, it was probably a power supply. I don't remember. So they immediately called the power supply people out and yelled at them. Right? Although nothing was bad with the power supplies after that week or prior, but that 1 week they yelled at them for what was going on. And it was 2 years prior. And like, really? What do you expect to get out of that?
Yeah.
Where did these units go? Where did these failures all occur? They were on a Navy dock storage facility for 2 years, and they pulled them out and tested them, and they all failed. Well, it might not have anything to do with the supplier or your manufacturing week. They all just happened to get bought and sold to somebody that abused them,
This shipping container was dropped 30 feet accidentally
into the ocean, and then they drained it out real quick and put it back up there.
Right. And we don't know, or they told us this, so whatever. Yeah, you'd have to. That's right. It would isolate. I mean, you could have in a bad, some parts of the world, the bad power inputs, poor voltage regulation, things like that. And so, that might identify special conditions like you talked about next to the ocean. You see a lot of that. And, when I saw pictures of computers sitting in they were on
the monsoon, basically.
Well,
in the gondola in Venice. And
I saw one where the guy had his desktop right on the window, near a window on the sea at the seashore. Yeah. And it was obviously all rusted and corroded in the back. But so those kind of thing obviously have a local cause, not necessarily the manufacturer, although. Then you might consider making a more robust product for that area,
But there's
tolerate for voltage variations, whatever.
But I'm going back to this idea of, if there's more than one solution to a particular problem. Here they have some data coming back to them from the field. They're doing some failure analysis. They're doing some debugging and repairing stuff, and they're gathering information in that process already. But it's on a spreadsheet or it's word of mouth. It's nothing formal. So many reliability folks will say, let's make this more systemic or more systematic, a process. FRACAS is It doesn't have to be, you don't have to buy the top end software package to do FRACAS. I've seen perfectly good ones that were on a chalkboard. We're dating myself a bit there, but they were on a chalkboard. And it's a small team, so they just kept a running list on the chalkboard and had next to it the status and who is supposed to be working on it. And they would sit down once a day or once a week and go, all right, this one's done. What's next? What's the next priority that I need to work on? If it serves the function and it's working just fine on a chalkboard, the reason to automate that or to put it online is that half your team's now in Singapore and the other half's here. So having a Google Doc or a Google Doc spreadsheet or something equivalent to that, a Slack channel or whatever, so that you have a common document that you can both edit. That's the next level. But do I need a big blue to artificial intelligence to peruse all this stuff and learn from it and eventually say, hey, you should work on this one? It's like, do I really need that?
Oh, Fred, I've just seen so many people in engineering want to go immediately to models and process and trying to use software to do something that they should get up off their ass and put their face into the product, unscrewing boards and taking things apart and investigating, going down to the warranty repair facility or wherever. They're just so reluctant to do that. And I don't understand this. No, I'm a qualitative, thinker. I had a tough time.
But you grew up doing field repairs, right? You started in industry.
Yeah, I was a field service engineer.
Yeah, that was your business is on that
That
deep
was
end.
what I did. I repaired and worked in a calibration lab repairing oscilloscopes and things like that.
And most people don't have that experience. They come out of school with textbooks,
they need to go
engineering, and that's it.
I know. They need the best, I would think the best reliability guys are those that worked in a failure analysis lab at that company or worked in field service or worked in the warranty repair group or something.
What about the statisticians? What about the statisticians?
Throw them out. Get out of here.
Hey, I resemble everyone.
Send them to the accounting department.
Oh yeah,
I don't know. That's where, right.
No, but I agree with you. Is that you need to understand failures.
I've had so hard many times that engineers are reluctant to go down to the lab or go down and get the product or have the product shipped to them to be able to look at it. It's just, there's a lot of hassles with that. I mean, it's not easy to doing those things either. So
no, I've run into it where, the team was, saying one of the best stories, I'll switch it around to not a disaster story, but a good story. This one group knew they were up on the rails of losing market share and all kinds of problems. And they knew that reliability was a big deal for their customers. And so they were designing a new platform and really trying to get it right. And so one of the many steps they did that contributed to their success was once the product launched, and it was not a, million onto the shelves all at once. It was, 10 gets sold here, 15 gets sold there. It was a very slow ramp that their market always did. And they put together a team of their key engineers basically and said, all right, you follow the shipment and go see it happen. And then you have fast tracked authority to change the design, right? We're going to really shorten the review process. And so you see something, you fix it, and let's get it out so that the next shipment or as soon as possible, we don't have that issue in the next rounds. And they called it the delta phase. So you've heard of alpha and betas, right? Right. And then you go to production.
Right.
But this was after production. It's just started, and it was, I think, for 90 days. They basically sent chunks of their design team to installations. And
great.
And they learned so much, and they drove their field failure rate to, and it started low because they did a lot of other things well in the design, but it started relatively low, and they cut it in half in 90 days, which was 3 times faster than they would normally do by just getting stuff shipped back to them or customers complaining, because they were there watching. And any little anomaly, they went, wait a sec, that shouldn't happen, because they could recognize what the difference between what was supposed to happen and what did happen. And then they would go jump on it. And it saved them a fortune and more than paid for all this travel and all this time with these guys going out there. And then those engineers came back and told amazing stories of what they learned about customers and how they used it and what they learned about the product. And there was a lineup out the door of people wanting to do it on the next program because it was an absolutely wonderful experience and educational about how well your actual design was right firsthand, right in the face of the customer, seeing it happen.
Right. And these are the things you can't learn in school. These are the things you have to go out. And that's what I really loved Click and Clack and the car, what was previously a car show.
Car Talk.
Yeah, Car wonderful Talk. Show. Two guys who got engineering degrees from MIT. And they themselves would say, look, you got to be really cautious about those engineers. And, from MIT. He says, they're never shown the real thing. They're just shown mathematical models of the thing. Yeah. and getting to see the real thing and touching it, like I had to crawl over ion implanters and replace vacuum tubes or vacuum section pipes and cryo pumps and diffusion pumps. And you just have to be there to know how complex and see what the issues are. And then the facility people and how they maintain it. You just learn so much about everything, about how they use, like you said. I mean, like those guys learned. Yeah. They saw that they met the people. And besides that, it's also very good for relationship building, especially if you're showing that kind of attention and everything. Even when one of the problems with a failed equipment, especially capital equipment in the field, is the customer has lost faith in that reliability of that system to operate. Yep. So you have to do, after you repair it, you have to do a lot of reselling of their confidence in the equipment and identify the problem. Say, we've found that problem and we've addressed it. And, and that's really.
But I always advise is then it's like McDonald's, would you like fries with that? Is once you say, thanks for letting us know that one. Here's the solution. How's that working? Anything else concerning you? Anything else you're noticing? And then be very willing to follow up on leads or hints or suggestions. There might be problems in the design or the way it's used or how they're using it or their understanding, or it might be, well, we need a new feature here. We need next generation. There's lots of benefits to doing that, but it's rare. And I agree with you. There's way too many engineers that just won't get out of their chair to go down to the manufacturing floor.
No, and since I had been a field service engineer, one time I also became a sales engineer after that. And so I was selling helium mass spectrometer leak detectors, and Vico had just made a portable one that was about the size of a large printer. And it was about 30 pounds, and it had a little ionizer. Do you ionize the gas and magnets and all that to make a spectrum of the mass? And you were looking for helium. Okay, so they had a filament in it, just like a tungsten filament. And as I had all these IBM engineers in the room, it burned up. But the great thing is, since I was capable and had worked on high vacuum equipment and pumps, I knew how to change this filament out. And in fact, they had already arranged for a second filament to be there. So I quickly, in front of them, demonstrated how to replace the filament. And of course I got the sale after that.
That's right. And you even sold them a couple of screwdrivers too.
Yeah. No, it's really important to interface with your customers.
Yeah. Well, it's one of those things. And the other part that's important, Kirk, is interfacing with us. So head over to accendoreliability.com/go/SOR.
What a segue.
You like that, huh? Yeah. And let us know what's on your mind, what questions you have. And, what's your story from your customer interaction type thing? There's got to be some stories out there that are just, or troubles. Maybe your organization won't let engineers out of the building to talk to anybody. Either way, or if you got something else in your mind, let us know. You can find Kirk and I and other hosts of the show on LinkedIn or on our About pages. And it's just another one of those things. If, learn how to do it well, then automate is kind of a mantra. And hopefully you get that out of this message here.
Right. First, learn yourself. First, get into the details. Look at the product. Get close to the customer and find out what's going on before you start to automate anything.
Yeah. Yeah, definitely. So anyway, have fun with that. We'll see if we can, and I know it's a manual process after we hit record to get this posted. So I'm going to get started with that. All right.
Okay, Fred.
We'll talk to you later, Kirk. Thanks a lot.
Okay.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.